All right. We're going to start here with just setting up a matrix from a word problem. So here we have, in a survey of 800 people, the following information was obtained. So when you're creating a matrix, you want to kind of think of it as a table. So if I want to sort this into data, what things could I sort? Like what are categories that I can break things into? Male and female, that's 2 categories. What else can I break it down to? The numbers are going to fall, yeah. And their opinion, right? So there's 2 categories for male and female, correct? And there's 3 opinions. Does that make sense? So when I'm looking at how to figure this out, I would establish what I have. I have 2 categories. So that will be 2 rows, exactly. So I could have a male row and a female row. And then we have how many opinions? 3. We have 3 opinions, right? We have a low, a high, and none, right? Yes. And so then when we fill this in, we're now saying, okay, this male, so this is a male, 175, and they are for high opinion, right? This is a male, they're for low, so males for low is 125. Males with no opinion is 50. Females, so 310 females had high opinion. 100 had low opinion, and 40. And that is how you turn it into a matrix. By how can you categorize the information? Does that make sense? So when you're reading the word problem, you're asking, okay, how can I separate this into different categories? Where do they cross? Where do they overlap? What is the time factor? Do you feel okay or feel like you would be comfortable creating your own matrix? Okay, because the matrix algebra isn't the hard part. It's taking the word problems, turning into the matrix, and then doing the math. Does that make sense? Okay. All right, so these are just examples of matrices, and I want us to go through making sure we can number them properly. So A, what are the dimensions of A? It is a 2 by 2. B, what are the dimensions of B?
1 by 3.
Switch it, it's rows and column. So it's a 3 by 1. And then C is a 3 by 3, okay? Remember, it's rows, then columns, RC COLA. Are we good? All right, now we're going to talk about finding the sum and difference. In order to add 2 matrices together, they must have same number of rows and the same number of columns. Okay, they have to be the same. If not, then there is no solution. Does that make sense? You don't proceed. Okay, so when you are adding, it is element to element, corresponding element. So if I am at row 1, column 1, then I'm adding to the other one that's in row 1, column 1. Okay, corresponding elements to each other. So we're going to start here. So we have matrix A and matrix B, and we want to add A plus B. When it says corresponding elements, 1 corresponds with 3, right? The reason why 1 corresponds with 3 is because they're both in row 1, column 1, right? So when you're doing your addition, you would have 1 plus 3, negative 3 plus 3, 5 plus, well, I'm just gonna write minus 2, is that okay? I have negative 2 minus 2. I have 0 plus 5, and I have 4 minus 6. So then my sum would be 4, 0, 3, negative 4, 5, negative 2. You remember this? Okay. Is subtraction any different? No, subtraction is ran the same. Corresponding elements to corresponding. So A, we have 1 minus 3. We have negative 3 minus 3. We have 5 plus 2. Why is it plus 2? The negative times a negative is a positive. We have negative 2 plus 2. We have 0 minus 5. And we have 4 plus 6. So our difference is negative 2, negative 6, 7, 0, negative 5, and 10. How do we feel? Okay, remember, when you're adding, that is commutative. I can move it, I can add in any order. Can I subtract in any order? No, we cannot subtract in any order. Order matters with subtraction. All right, what are your questions you have for me? None? Y'all remember seeing this before, right? It gets weird with the multiplication. Michael was saying it gets weird, right? Yeah, it does. Sorry. All right. We're going to start with easy multiplication, which is scalar multiplication. With scalar multiplication, what that means is that you have a matrix with a number outside of it. Scalar multiplication is pretty much distribution for matrices, right? What this means is that every number is going to be multiplied by 2. So it becomes 2 times 1, 2 times 2, 2 times 3, 2 times, that's weird. Go with it. 2 times 4. So our product here would be 2, 4, 6, 8. Remember that? Questions about scalar? All right, so we're still on the easy side. Cool. All right. So I'd like for you to give us some practice with your scalar multiplication and see what happens. On A. So 3 times A means every element in A is multiplied by 3. So you are just testing out your multiplication skills here. 9, 3, 15, negative 6, 0, and 18.
What? Whoa.
Oh my gosh, mind's blown. It was crazy, so difficult, so hard.
That's really hard. Oh my God. Oh my God.
I know.
Oh my God,
I don't know. The struggle is real out here.
It is.
On C, it's a fraction. So that means you're multiplying by the numerator, dividing by the denominator. So 9 times 2/3 is 6. Yes. 2/3 times 0 is 0. 2/3 times negative 3 is negative 2. And 2/3 times 6 is 4. How we do?
Oh, I'm dumb.
You know why I'm quick? I divide first and then multiply. I make it small, then go big.
Oh, wait, no, I'm not. I'm not dumb. I'm right.
I am smart because I use that method. Duh. All right. All right, last one. So you had to double everything in A, triple everything in B, and then subtract them. Is that accurate? All right. So we have 6 minus 12. No, I'm not. I'm just going to write negative 6. Then we had 2 minus, where we at? 3? 2 minus 3 gives me negative 1. Then we had 10 minus 0, which is just 10. Then we had negative 4 minus 24, which gives us negative 28. Then we had 0 minus plus 9, which is 9. And then we had 12 plus 9, which is 21.
Wait. You skipped one. That's 0.
Where am I at? 0.
0 times 2 is 0.
I don't know. I think I did 8. I don't know.
1. Good job. That should be
Son,
negative
what are you
3.
doing?
No? Good job.
Nothing.
Sorry, no, but you
And
are
then-
not.
6 and 2 is 12.
And 12 plus 9. 12 plus 9 is,
Negative 3, so that's.
it's a -3 and a -3, which makes a +9, which makes 21. I just made one little boo-boo right here.
Just making sure.
I was trying to visualize. Did you write it all out? Did you visualize?
Oh, I didn't.
You wrote a lot of it.
I love doing this kind of math.
All right.
So neat.
So we're good? You're good with those two types of matrix algebra, right?
Yes, ma'am.
All right. And like Michaela said, here's the fun part, the actual product of two matrices. Okay? So actual product of two matrices. I don't know if y'all remember when I talked about the smile check. So in order for two matrices to be added together, if I have M by N times N by K, these two have to be the same. So they have to smile at you. If they smile at you, then there is a product. If they don't smile at you, okay? And then the product would have to be the number of rows and number of columns that are left. My pen needs to tip change. That's what that is. Okay? So it would produce an M by K matrix. When we are doing this, so your number of rows and your number of columns on the other one, they have to be equal.
Oh, I remember this. I
Mhm.
don't remember how to do it.
Row column. All right, so here we go. You are multiplying and adding. Anyone like ringing any bells at all?
Yeah, I remember it was I know. I just
What-
remember that it exists.
Oh, okay. This is where we'll kind of remember, because we have to do, so it's this guy times this guy,
Wait, okay.
and then you're gonna keep going, plus, so it would be -2 times 3 plus -2 times 0
Oh my God.
plus
Oh my God.
negative-
No.
-2 times -2.
Oh,
plus-
wow.
Y'all remember?
Yes. Because I'm mentally pushing because I don't.
We'll just pick up here on, what's that day called? Monday. Yes. This is where we'll stop.
Each number